Section 2.8 begins on page 132 of your textbook. It covers graphing linear inequalities in two variables. So before I get to linear inequalities, I want to talk about a linear equation. So this is a linear equation, y equals 2x plus 1. In order to graph it, it is in slope-intercept form, so I want to go up on my y-intercept, 0, 1. My y-intercept, and then I want to use my slope, which is a positive 2, so that means it is 2 over 1, 2 over 1. So I go up 2 to the right 1, up 2 to the right 1, and this is my linear equation. A solution is any point that falls on that line, because it would produce a true statement. So, for example, if x equals 1, you are to find what y equals, and y would equal 3. Y would equal 3. So 1, 3 is a point on the line, and that is what is considered a solution. It is something very similar when you have a linear inequality. So there are 4 types of inequalities: greater than, less than, greater than or equal to, and less than or equal to. And a solution is going to produce a true statement also. So let's switch it up a little bit and have y is less than 2x plus 1. So if I were to simply check if a coordinate pair or a point in x comma y, if it were a solution, then all I need to do is substitute in the values. So let's check 0, 1. So that means I substitute 1 in for y and 0 in for x. So 2 times 0 plus 1. So I would get 1 is less than, 2 times 0 disappears as it becomes 0. 1 is less than 1. This is actually not true. So that means 0, 1 is not a solution. Let's check the point 2, 2. If I were to substitute in these values, 2 for y and 2 for x, I get 2 is less than 4 plus 1, so 2 is less than 5. This is true. That means this is a possible solution. Is a solution. Alright, so now, in order to graph linear inequalities, we are graphing lines. So let's look at a couple of examples. So, x is less than 2. So you graph it just like it was the line x equals 2, and then we have to shade a part of the graph. So x equals 2 means I move right 2 on my x-axis, and that becomes a vertical line. Alright, so one thing I do want to cover is since it is less than, that means it's going to be a dotted line. I do not want a solid line like I have drawn to the left, because that includes when x does equal 2. So I want a dotted line. Alright, that's going to be one thing on the graphs on your test that I will be looking for. So is it a solid or dotted line? If it was less than or equal to, that means it would be a solid line. Alright, and so then we can use a test point. We can always use a test point to see which part of the graph, since it is an inequality, which part of the graph I want to shade. Your nicest test point is the origin, 0, 0. However, if your line that you are graphing passes through the origin, you are to pick a different test point. For example, you could pick 1, 1, or 10, 10, or 0, 1, any point on one side of the graph. So, there is no place for me to substitute in this y value, so I'm just worried about x. So you substitute 0 in for your x, and 0 is less than 2. 0 is less than 2. So, there was my test point. Since that is true, I want to cover it and include it. So I'm going to be shading the left side of my graph here, making sure since my test point came out to a true statement, I want to include it in the solution. Alright, let's look at another example. y is greater than or equal to negative 2. Y is greater than or equal to negative 2. So I graph it by going down 2 on my y-axis, and I see, is it going to be a solid or dotted line? It will be a solid line. Since it is equal to, I want to include it. Alright. And now I use a test point not on that line. So again, I can use 0, 0. Here there's nowhere to put that x equals 0, so we're just using y. Y is going to be 0. So is 0 greater than or equal to negative 2? That does happen to be true. So here's my test point at the origin. Since that was true, I'd want to cover it. Alright, let's look at another example. Y is going to be greater than negative 2x plus 3. Alright, so you go up 3 on your y-axis to your y-intercept, and then you go down 2 to the right 1 by your slope, down 2 to the right 1. Alright, and that means it's going to be a dotted line since it's just greater than. And then you use a test point. 0, 0 happens to not be on our line again. So in this case, you do need to plug in both your x and your y. So 0 is greater than negative 2 times 0 plus 3. So 0 is greater than 0 plus 3. 0 is greater than 3. In this situation, here's my test point. In this situation, this is false. 0 is not greater than 3. 0 is less than 3. So I don't want to cover that point, and I don't want to include it. I want to cover the other side. I don't want to cover that side that that false statement was on. Alright, so let's look at another one in standard form. So let's say this was 3x minus 4y is less than or equal to 12. Now we had talked about this form in class, standard form, and how you are more than welcome to solve it and put it in y equals mx plus b into slope-intercept. However, we'd also discussed where some issues might occur when I'm dividing by that negative 4 and I forget to flip my sign. So we're going to go about it in standard form. So that means you can find your x-intercept and your y-intercept and then connect those 2 points to create your line. So for your y-intercept, you plug in 0 for x, so you get 3 times 0 minus 4y is less than or equal to 12. And I told you that when we're finding our intercepts, you can pretend for a second that that is an equal sign. So that term disappears. Negative 4y equals 12, and we have to divide by negative 4 to get y equals negative 3. So our y-intercept is going to be 0, negative 3. Next, for our x-intercept, I'm going to be plugging in 0 for my y, since your x-intercept lies on your x-axis. And I get 3x minus 4 times 0. And we're pretending that is an equal sign again for the time being, just to solve. X equals 4. Right, so I go to 4, 0. And then our symbol here, less than or equal to, tells me that it's going to be a solid line. Alright, there is my solid line. And now I want to use a test point to figure out which side to shade. So my test point is going to be 0, 0. And since it is in standard form, when I plug both the zeros in, it works out really nicely. So I get 0 minus 0, which is 0, is less than or equal to 12. So is this true? It is true, so that means 0, 0. I want to cover my side of the graph that true statement is on so that I can include it in my solution. Alright, if you guys have any questions on how to graph linear inequalities, whether a line should be dotted or whether it should be solid, and which side to shade, please feel free to see me in the morning or email me with questions.